In April 2024, Reuters published a report claiming Tesla had quietly canceled its low-cost vehicle project, supposedly due to growing competition from Chinese electric car manufacturers. Elon Musk swiftly responded by dismissing the report as false, calling out Reuters directly with a blunt statement: "Reuters is lying." Now, a year later, the developments in the real world tell a very different story. Tesla has not withdrawn from its vision of delivering an affordable electric vehicle to the masses. Instead, the company has doubled down on its efforts, with major expansions underway at Gigafactory, Texas, Gigafactory, Nevada, and the company's Megafactory in Lathrop, tailored to support a new compact vehicle platform. The global push is also intensifying, with Tesla preparing to open its first showrooms in India and more planned throughout Europe, pointing to a strong global strategy behind the upcoming release. Though Tesla has not officially referred to the car as the Model 2, the industry trends and enormous factory investments would strongly imply that mass production of this groundbreaking vehicle is well underway. It represents more than just a new model. It signals a major technological leap that Chinese automakers are unlikely to match anytime soon. This upcoming car is powered by a new generation of axial flux motors paired with an advanced battery technology known as the quantum-enhanced graphene 2680 cell, which is structurally integrated into the car's frame. The introduction of axial flux motors marks a major departure from Tesla's previous engineering standards. Unlike the radial flux motors used in all current Tesla vehicles like the Model 3 and Model Y, axial flux motors have a significantly different internal configuration. Rather than a cylindrical shape, they feature a flatter, disc-like build, typically measuring only 80 to 100 millimeters in thickness, much thinner than the over 200 millimeters seen in radial counterparts. The flat configuration enables the magnetic fields to operate along the axis rather than radially outward. Testing in both labs and on the road has shown that axial flux motors can convert electrical power into mechanical torque up to 30% more efficiently, especially during stop-and-go urban driving where typical motors lose performance. Tesla's decision to adopt axial flux motors isn't just theoretical. The motor's torque increases exponentially with rotor diameter. For instance, increasing the diameter from 250 mm to 300 mm can raise torque output by over 40% while maintaining a consistent motor thickness. In real-world terms, this means Tesla can achieve peak torque figures exceeding 500 Nm from just a single compact motor, performance levels typically associated with dual motor configurations. Simultaneously, axial flux motors are as much as 50% smaller in volume compared to equivalent radial flux units. This efficiency in size allows designers to reclaim around 70 to 100 liters of internal vehicle space, which improves interior design, passenger comfort, and trunk capacity. It also enables engineers to lower the vehicle's center of gravity by up to 15 millimeters, contributing to better handling and ride dynamics. Another major advantage is the improved thermal management of the new motors. Due to their flat shape, heat disperses more evenly across the surface, unlike in radial motors, which depend on narrow internal cooling channels that can create hotspots. This new setup reduces peak temperature concentrations by up to 25%, ensuring stable performance, even during rapid acceleration or in hot environments where the ambient temperature exceeds 35 degrees Celsius. For the average driver, all of this translates into an enhanced experience. Acceleration becomes smoother and more linear, achieving 0 to 60 miles per hour in about 5.9 seconds. Which is notably quicker than most compact electric vehicles in the same price bracket. Reduced internal energy loss means that the same battery pack can deliver an additional 30 to 40 miles of range on a standard 300-mile rated battery. The vehicle's ride is also quieter, with axial flux motors producing 30% less vibration and noise, resulting in a cabin that's between 3 to 5 decibels quieter on average. This new motor design further simplifies the vehicle's mechanics, with 25 to 40% fewer moving parts than conventional motors. Components such as internal bearings and seals, which often require maintenance or wear out over time, are largely eliminated. As a result, Tesla estimates that Model 2 owners could save between $600 and $1,000 on maintenance over an 8 ownership period. The end result is a car that offers a smoother, quieter, more efficient driving experience while also keeping long-term costs lower for everyday consumers. But the transformation inside Model 2 doesn't end with the motor. Perhaps the most revolutionary change is hidden in its battery system, a new class of energy storage that Tesla has been quietly developing since 2023, known as the quantum-enhanced graphene 2680 battery. This next-gen energy source marks a dramatic leap beyond conventional lithium-ion technology. Instead of using standard graphite electrodes, the 2680 cell uses pure graphene layers for ultra-fast electrical conduction. It's also enhanced by a thin layer of quantum dots that manage thermal behavior on a microscopic level in real time. The combination of high conductivity and intelligent heat regulation results in a battery system that's smaller, more efficient, and significantly more durable. Tesla's choice to use the 2680 cell over the more widely publicized 4680 format is deliberate. These 2680 cells are about 40% smaller, making them ideally suited for compact electric vehicles like the Model 2. The smaller form factor permits a more adaptable battery layout throughout the vehicle's frame and simplifies the production process. Tesla estimates that manufacturing waste can be cut down significantly, leading to a 25% reduction in overall battery production costs. Thanks to its optimal surface area-to-volume ratio, the 2680 cell is also better at dissipating heat, which complements the thermal control provided by the embedded quantum dots. The quantum dots function as thermal sensors and regulators. They emit specific wavelengths of light at different temperatures, which allows real-time thermal feedback and adjustment. As the battery heats up, the quantum dots work with the graphene's fast conductivity to regulate the flow of electricity, thereby preventing overheating and degradation. With better distribution of heat across the pack, the battery experiences fewer hotspots, which not only preserves performance but extends lifespan. Over time, the battery system even learns from driver behavior, adapting its internal settings to enhance efficiency and longevity. Tesla has further innovated by integrating the 2680 cells directly into the vehicle's frame, making them a structural element rather than a standalone battery pack. This approach removes the need for bulky housings and complex cooling systems. Instead, the battery structure contributes to the vehicle's overall rigidity and safety. Heat distribution across the frame is improved by the network of quantum dots, enhancing thermal control without added weight. The flexibility of placing these smaller cells throughout the vehicle allows for optimized weight distribution and interior space, benefiting both safety and passenger comfort. Structurally, integrated batteries provide major gains in performance and efficiency. Tesla projects that the Model 2 will weigh up to 30% less than comparable EVs, while the rigidity of the frame could increase by 40%. The energy density of the battery improves by 20% within the same footprint. A lower center of gravity enhances driving stability, and the lighter structure supports quicker acceleration and shorter braking distances. The cabin becomes more serene, with fewer vibrations and more acoustic dampening from the integrated components. The structural layout also increases crash safety, as it helps absorb impact more effectively. All these improvements culminate in making the $9,875 price tag of the Model to not only possible but practical. The advanced battery technology alone cuts down around 22% of the car's total cost, compared to traditional lithium-ion systems. Tesla's integrated 2680 setup saves approximately $6,500 per vehicle. With charging speeds that allow 0 to 80% in just 6 minutes, range anxiety is practically eliminated. The battery's size also means it can be charged efficiently even at standard 110-volt outlets, making it home charging faster and more accessible. Moreover, its lifespan far exceeds industry norms, with an estimated longevity of up to 1 million miles, dwarfing the current 300,000-mile standard. Once mass production starts in 2026, Tesla expects a 65% drop in battery production costs due to simplified manufacturing and reduced dependence on rare materials. The Model 2 also redefines what it means for a car to be smart, not by relying on gimmicks or flashy features, but by enhancing everyday convenience. Instead of putting emphasis on massive touchscreens or autonomous driving demonstrations, Tesla's vision of smart living centers around subtle,
so unless there's a major breakthrough in full self, they're both truly competing to prove who the real pioneer of EVs is.
Preferred departure times, and charging routines. It adjusts its route planning using real-time traffic data gathered from millions of Tesla vehicles and optimizes charging schedules based on local electricity rates, which in areas like the US can vary up to 40% between peak and off-peak times. This can save drivers hundreds of dollars annually.